Hi everyone, welcome to Drawing Hub. This is Sanjana, and in this video we'll be continuing with operating system of module 1. This is part 2. Okay. Interface. What is interface? Interface is used in order that user interface acts with a computer mutually. It controls how to input data and instruction and how instruction is displayed on the screen. So it is an intermediary, or it can say interface is an intermediary that acts between the user and the system. So in such a way that usually we use interface so that it is easy for the user to use. Okay. Now we have different three types of interface. We have command line interface, batch interface, graphical user interface. Okay, command line interface or CLI, command line. So we can, from the word, everything is understood from the word itself. Text commands and methods for entering them. Use text commands in case of command line interface. In case of batch interface, commands and directives to control those commands are entered into files. Okay, commands and directives are entered into files, and then we will execute that file. That is batch interface. Graphical user interface, that is, it's a Windows system with a pointing device to direct IO. Choose from menus, the usual things which we say, that is inside a phone we see the application, so we can easily interact with it. Those are graphical user interfaces. We don't have to go search for them. I mean, for example, if I'm taking this OBS studio, I can just go over here, I can click over here, if I click over here, it will be stop recording, I can start streaming, I can do many things over here. So this is much more understandable for me rather than going in and typing commands. So that is the difference. Okay. So here command line interface means I have to enter the commands, I have to enter the text commands. Batch interface means commands and directives will be entered into a file and that file will be executed. Graphical user interface means it is much more easier way for the users to use it. It is in a Windows system. We can choose from the menus, or we can make selections and a keyboard to enter the text, and it's done in a much more easier way. Now, what is booting? Booting is nothing but starting. The process of starting the computer is called as booting. So, OS starts the computer to work. Okay, it checks the computer and makes it ready to work. Okay. Booting means when the computer is being started, that process is called as booting, and OS starts the computer to work. So when the computer is being on, the OS will start. For making the computer work, OS have to help the computer. It checks the computer and makes it ready for work. Okay. Then we have computer system architecture. We have different types of computer system architecture based on the number of general purpose processors. It is divided into three. I have single processor system, multiple processor system, a multiprocessor system, and clustered system. Okay, what is this is based on, this classification is based on the number of general purpose processors. That is why the name itself says processor system, single processor system, right? Again, from the name here we can understand, single processor system means one processor system. That is, in this case, in single processor system, one main CPU. This will be capable of executing a general purpose instruction set, including instructions from user processes. So in the single processor system, one main CPU which is capable of executing a general purpose instruction set, including instructions from user processors, are used. Also, almost all single processor systems have other special purpose processors as well, because single processor means only there will be one main CPU, and in order to help this single processor system, it will have special purpose processors also with it, and they may come in the form of device specific processors. Okay, so these can be device specific. A device specific means it can be a disk, it can be keyboard, graphic controllers, and etc. So device specific processors also. Now, special purpose processors have limited instructions. We are talking about special purpose processors right now. Okay, so they have limited instructions and do not run user processes. Okay, sometimes they are managed by the operating system, in that the operating system sends them information about the next task and monitors their status. So in single processor system, there is one, okay, I'll just revise. In single processor system, there is one main CPU and this will be capable of executing a general purpose instruction set. Also, those which includes those instructions from the user processors also. And almost, okay, not all, almost all single processor systems have other special purpose processors also along with it. And these special purpose processors may come in the form of device specific processors. It can be disk, keyboard, graphic controllers and all. Now the special purpose processors have limited instructions, okay, and they do not run user processors. These special purpose processors have limited instructions, there is no T over here, and do not run user processors. Now, sometimes they are managed by the operating system, in that the operating system sends them information about their next task and monitors their status. Operating system will send the information about the next task and then it will monitor the status. Okay, that is single processor system. Then we have multi-processor system. Multiple processor system. Now, so they have two or more processors. Single processor was called because it only had one main CPU. So in multiprocessor, it will have two or more processors in close communication. And this will be sharing the computer bus, it will be sharing the clock, memory, peripheral devices. So it will be sharing all these things because they are in close communication. Multiprocessor system first appeared prominently in servers and have since migrated to desktop and laptop systems. Just an example of where it is being used right now. Multiple processors have appeared on mobile devices such as smartphones and tablet computers. Again, example where it is used now. Usually, before it was there in servers, then it have migrated to desktop, to laptop systems, now to smartphones, tablet computers. It is used. Multiple processors are used on mobile devices also. So this is a figure of multi-processor system. And how is this coming? Okay, I have multiple processors. This is my one processor, this is my second one, this is my third one. I have multiple processors. So CPU 0, and I have numbered it 0. This is one of my processor, this is another one, this is another one. Okay, and inside them I have registers, I have cache. They are all same. I have registers, I have cache. In all this processor I have the same thing, and then they are all connected to one memory over here. They are connected to one memory over here. Okay, so multi-processor system, they have two or more processors in close communications, and it will share the computer bus, the clock, memory, peripheral devices, everything. Okay, now what are the advantages of multi-processor system? Okay, we have different advantages like increased throughput, economy of scale, increased reliability. Okay, as of now, just learn 3 advantages of multiprocessor system. Increased throughput. So, when the number of processors are increased, we will expect to get more work done in less time. So, throughput, increased throughput means I need to do more work in less time. I need to do more work in less time. So, the speed up ratio with n processors is not n, it is less than n. So, due to contention of shared resources, n programmers working closely together do not produce n times the amount of work a single programmer would produce. You don't need to get confused with all these n ratio things and all. See, if there are n number of users, okay, there are n number of single users, okay, or say we are not looking single user, there is just one user and his name is n. Okay, there is just one user and his name is n. His work done is n, and he can produce n number of things. Okay, n number of things is what he can produce. Now, I'm having 3 people, they're also n. Okay, they are also named n. The work produced by each of them is n. So, the product they are producing will not be n, it will be less than n. It will be less than n. That is the time they take will be less than n, and the work they have done will be more. That is what this line actually means. The speed up ratio with n processors is not n. See, n processors are being used, so the speed up ratio is not n, it will be less than n, because shared resources are there. They are working together, they are not working alone. So n programmers working closely together do not produce n times the amount of work a single programmer would produce. So if this person could only do n work, these 3 people can do 3 times. So that is good, that is an advantage. That is why increased throughput is an advantage, increased throughput. Then economy of scale. Multiprocessor systems can cost less than equivalent multiple single processor system. So economy of scale means if we assemble multiple, we know what single processor system are, right? So if we assemble all this single processor system, multiple single processor system, even then the cost will be more. But if we have one multiprocessor system instead of those multiple single processor system, that will cost less, because the multiprocessor system, they will share peripherals, they will share, they have mass storage, power supplies and all. So if several programs operate on the same set of data, it is cheaper to store those data on one disk. Okay, it is cheaper to store it in one disk rather than having multiple single processor system. That is the economy of scale. Then increased reliability. Now, if functions can be distributed properly among several processors, then the failure of one processor will not halt the system, it only slow it down. So, in case of if there is only one single processor, you compare it and study with the single processor system, it will be easy for you to understand. So in case if you have only one processor, that is in single processor system, if there is some failure inside this one processor, the whole system will crash. But in multiprocessor system, if there is an issue, if functions can be distributed properly among several processors, even if there is an issue in one of the processor in the multiprocessor system, it will not stop the system as whole, it will just slow it down, because there are other processors inside this also. That is increased reliability. The users can rely on multiprocessor system. Okay, the advantages of multiprocessor system are increased throughput, economy of scale, increased reliability. Okay. Now again, multiprocessor system, have a little bit to learn. In multiprocessor system, there are 2 types. Asymmetric multiprocessing. Okay, if one is asymmetric multiprocessing, the other one is symmetric multiprocessing. So asymmetric multiprocessing means here they are having a master-slave relationship. Asymmetric. There is no equality. There is some sort of asymmetricity inside it. So master-slave relationship also, that is another name of this asymmetric multiprocessing. Some systems use asymmetric multiprocessing. Here what will be there? There will be a boss processor or the master processor, and this boss processor or this master processor, the master will be controlling the system, and the other processors are the slaves, right? They are the slaves. Okay, either look to the boss for the instruction, they'll be waiting for the boss for the instruction, or they'll have some predefined task. Here there will be a boss worker relationship. In context, if we refer it to with a company type, then boss worker relationship is there. Now the boss processor schedules and allocates works to the worker processor slave. Okay, here we have an example of asymmetric processing. I have a master slave. Okay, now this master slave, in this master slave relationship, I have a master processor. The master processor will send instructions to the slaves, and I have here slave 1, slave 2, slave 3, and these slaves, each of them will be performing each processor's process. Okay, slave 1 will be performing process 1, slave 2 performing process 2, slave 3 performing process 3. Each of them will be performing each of the process. This is asymmetric multiprocessing. This is what is it. P1 is for slave 1 and P2 and P3 for slave 2 and slave 3. That is asymmetric multiprocessing or master-slave relationship. Now, symmetric multiprocessing means all the processor perform all the tasks which is there in the operating system. Here, there is no boss-worker relationship between the processors. They are just peers. Everyone is equal. Okay. So, symmetric multiprocessing means there are different, okay, multiprocessing means there are different processors. Okay, so there CPU 1, CPU 2, CPU 3, and they all will perform the processes. Okay, so this is a symmetric multiprocessing architecture. This is the architecture of multiprocessing alone, multiprocessor. And this one is of symmetric multiprocessing. Okay, and this is a dual core design with 2 cores placed on the same chip. That is again of multiprocessing, but with 2 cores. That is about multi-processing systems. Okay, multiprocessor system, I hope it is clear. Then, okay, again in multiprocessing system, we have told what it is. It is the 2 processors or more processors should be there in close communication. We have discussed the architecture, then the advantages like increased throughput, increased scale, then increased reliability. Then there are types of multiprocessor have asymmetric and symmetric. Asymmetric is having a master-slave relationship and symmetric is having a peer-to-peer relationship. Then we are coming to clustered system, network operating system. So another type of multiprocessor system. Okay, we can say clustered system is another type of multiprocessor system, but we have classified it as a whole different thing. So here multiple CPUs are coupled together. Individual systems are coupled together. So it is not a single processor. It is the multiprocessor, but in another term. So here we are coupling multiple multiprocessor systems. In multiprocessor system, single processor systems are combined, and in clustered system, multiple CPUs are clustered. Okay, brought together. So clustered systems differ from the multiprocessor systems in that they are composed of 2 or more individual systems or nodes joined together, and they are loosely coupled. Now, each node may be a single processor. Okay, it can be either a single processor system or a multi-core system. Clustered computers share storage and are closely linked by, okay, and these clustered computers, they are connected through local area network or maybe a faster interconnect, and they are usually used to provide high availability service. That is, service will be continued even if, so the service in order to give high availability of service, we are using this clustered architecture. Okay, here even if there is a failure in one particular system, the cluster it will continue to operate, and each node can monitor one or more of the other over the LAN. See, it is connected to local area network, right? So the monitors, each node can monitor each of the others, and if the monitored machine fails, the monitoring machine can take ownership of its storage and restart the application, okay, that were running on the failed machine. And now this is the general structure of a clustered system. I have different computers, and these computers are interconnected. As you can see here, they are interconnected, and there will be a storage area network, and it is connected to that. So even if there is some issue, say so there is some issue in this particular computer, it is failed, or there is some issue, it has gone to a hold, then what will happen, since it is interconnected with this particular person, with this particular computer, then what will happen, all the information is already here inside this. So this will take up its work and start doing it. There will be no issue. Now clustering, okay, you can just draw all these figures because all these are important. Okay, and now clustering can be structured asymmetrically or symmetrically. So if we are talking about an asymmetric clustering, one machine is in hot standby mode while the other is running in the application. Okay. The hot standby machine does nothing but monitor the active server. Okay, I have asymmetric and symmetric. In asymmetric clustering, say there are two machines. One is hot standby mode and the other will be used to run the application. This is the hot standby one. This hot standby one will monitor the active server. The other one will be running the application. Now, if it will be monitoring the server, and if that server fails, the hot standby host will become the active server. It will take the position, like you can call an assistant, hot standby mode. That is about asymmetric clustering. In symmetric clustering, two or more hosts are running applications and are monitoring each other. So there will be two or more hosts that will be running applications, then it will be monitoring also each other. And symmetric clustering is much more efficient as it uses all of the available hardware. Since cluster consists of several computer systems connected via network, clusters can also be used to provide high performance computing environments. Now, such systems can supply significantly greater computational power than single processor or even SMP systems. Okay. So, inside the clustering system, what all did we learn? Clustering system, it is a cluster of different multiple processor system and it is connected through local area network or a much more faster interconnect way. And then it is used to provide high availability service. So even if one system fail, it will just keep continuing with its work. And this is the general structure of a clustered system. The computers are interconnected to each other. Then we have symmetric and asymmetric clustering. Asymmetric clustering means it have a one machine will be hot standby mode and the other one will be running the application. Hot standby mode host will be hot standby host machine that will be monitoring the active server, and in case that server fails, the hot standby host will become the active server. The other one will be running the application only. In symmetric clustering, two or more hosts will be running the applications and they will be monitoring each other also. And this is said to be more efficient because it uses all of the available hardware. Now, since cluster consists of several computer systems, so inside a cluster there will be so many computer systems and they are connected via network. That is why we say that these clusters can also provide high performance computing environment. Also, such systems can supply significantly greater computational power, more computational power than single processor system, okay, or symmetric multiprocessor system. So it is, this one is more better, this structure, this symmetric clustering mode is much more better. That is what it's meant to say. So we have learned about the three types of architectures, right? What all did we learn so far? Okay, in computer system architecture, we have studied about single processor system, multi-processor system and clustered system. We also said what booting is and the interfaces like command line interface, batch interface, graphical user interface. Okay, that's it. Okay. So till next video, bye bye.